840 tons. That's the BelAZ 75710 fully loaded, the largest dump truck ever built. But how do you engineer something this massive to actually move, steer, and survive the world's most punishing mines? In modern open-pit mining, operational success is measured in pure volume. When operations require moving millions of tons of earth daily, standard haulers look like toys, choking transport routes and draining fuel budgets. This bottleneck created a desperate engineering challenge: scale up or face financial ruin. But simply scaling up a normal chassis would cause the metal to snap under its own weight, and standard tires would shear apart under the friction. This was not about building a big truck for the sake of a record. It was about surviving a brutal economic reality under immense physical pressure. To crack this hauling crisis, a team of designers in Jodzina, Belarus, set out to completely rewrite the laws of heavy transport. This task fell to BelAZ, a state-owned Belarusian manufacturer founded in 1948 that had spent decades turning massive mining machinery into a national engineering identity. By the early 2010s, existing ultra-class haulers maxed out at 400 tons, leaving a glaring operational gap at the absolute limit of open-pit mining. Chief designer Alexander Igorov championed a capacity-first approach, engineering a vehicle that bypassed standard design limits entirely. In September 2013, the factory gates opened to reveal the prototype to the world. By October 2014, the first machine bypassed showroom vanity and plunged directly into commercial service at a Siberian coal mine. It was no longer a theoretical concept. This was an active tool designed for the heaviest operations on Earth, born from a factory specialized in brute force engineering. Spreading the crushing force of a loaded mountain required a radical structural departure. Standard haulers rely on 6 tires, but this colossus distributes its burden across an 8-wheel, dual-axle footprint. This setup prevents the machine from sinking straight into the muddy, shifting floors of open-pit mines. But keeping this giant mobile demands more than extra rubber. Both the front and rear axles steer actively using high-pressure hydraulics. This 4-wheel steering swings the massive tires in opposite directions, shrinking the turning radius to just 31 meters, allowing a vehicle as long as a house to navigate tight switchbacks. Underneath, a high-strength steel frame flexes to absorb violent impacts, supported by pneumatic springs and hydraulic dampers. High above the dust sits a vibration-isolated, climate-controlled cabin, where dual digital screens and 360-degree cameras keep operators safe during grueling 12-hour shifts. These massive components translate into numbers that completely redefine heavy industry. The BelAZ 75710 holds the Guinness World Record for the largest payload capacity on Earth, engineered to haul an incredible 450 metric tons of rock in a single trip. Moving that much ore requires unprecedented structural mass. The truck itself weighs 360 tons empty, meaning the chassis bears a massive burden before a single ounce of payload is even loaded. Once filled, the gross vehicle weight reaches up to 840 tons. Its physical footprint dominates the pit, stretching 20.6 meters in length, spanning 9.87 meters in width, and towering 8.26 meters into the air. It rolls on 8 colossal 5980 R63 tires, each standing 4 meters tall. Yet, even at this gargantuan scale, the truck can still sprint at a top speed of 64 kilometers per hour. Powering this speed, this Titan abandons a traditional transmission. Instead, two 65-liter 16-cylinder MTU diesel engines generate 2,300 horsepower each. This combined 4,600 horsepower setup drives onboard generators that send electricity directly to 4-wheel-mounted AC traction motors. When traveling empty, the system shuts down one engine to save fuel, using regenerative braking to capture energy on downhill slopes. Unloading relies on a hydraulic hoist operating at 26 megapascals. 4 double-acting cylinders lift the heavy bed, dumping the payload in just 26 seconds and lowering it back down in 20. Deploying this extreme engineering into active service is a cold, calculated business decision. A single BelAZ 75710 demands an upfront investment of $6 to $9 million. Once on site in massive open-pit coal and iron ore mines, the daily operating expenses are equally staggering. Each of the 4-meter-tall tires costs up to $200,000 to replace, with high-usage mines burning through 4 wheels per year. Fuel consumption averages 1,300 liters per 100 kilometers, translating to roughly $13 of diesel for every single kilometer traveled. Yet, in high-yield operations like the Kuznetsk Basin, these massive outlays make financial sense. By slashing the number of haul cycles by 25%, this single titan outproduces entire fleets of smaller trucks, turning extreme scale into pure profit. This colossal titan proves that human ambition has no limits. As engineering marches forward, it remains the ultimate conqueror of the deep. Share your thoughts below.